So our first speaker is Susan Long, who is the Innovation Advisor for Syria for an organization called Field Ready. And Susan is going to talk about reconnecting search and rescue efforts in Syria. And the floor is yours.
Thank you. Hi. So I'm Susan from Field Ready, which is a non-profit of chiefly consisting of humanitarians and engineers, and we're around the world. We have people in the US, in the UK, in Nepal, in Jordan, in Australia, South Sudan, and Iraq, and Myanmar, all these coming and going. And so to start say Field Ready really grew out of the founders' frustration with these kind of supply chains for getting things into areas after conflicts or emergencies, that even the simplest items can take months and be very expensive to get from manufacturers to the people that need them. And so the idea was, how do we get the people who are making things and the people who need the things closer together? And to begin with, Field Ready was really about can we make use of sort of affordable new technologies to allow things to be made in the field, to answer the demand there. So in this case, it's sending an engineer with a 3D printer connected to a Land Rover into rural Nepal to IDP camps. Where increasingly Field Ready is focusing, and I think the sort of really exciting bit for the future, is how to actually create the spaces and the systems that it kind of becomes the norm to have distributed manufacturing and have things made where they're needed around the world. So I'll kind of come on to that, but I thought I'd quickly run you through some of the things that we've actually made. Gives it a bit of a tangible interest. So one of the very first things, pretty straightforward, a displaced person camp in rural Nepal, leaking water pipes, and they don't have the correct fittings. And so the engineer on the ground was able to sort of take the measurements, make the bespoke pipe fitting, and 3D print it within an afternoon. And from this, actually went on to develop an app in conjunction with Imperial College London, so that people who don't have any skills in CAD can just put in the dimensions and get the parts printed out. Rural Haiti, healthcare clinics. This is actually an umbilical cord, and nurses were tying the umbilical cords with string or with the hair clips, which is pretty bad from a sort of hygiene point of view. So our engineers spent some time with them, printing parts, iterating, making the parts again with feedback from the midwives till they had a final part, which now have healthy babies. Quite a lot of medical equipment being made over the time that we've been working, including an otoscope and a fetoscope. A lot of this stuff was originally made for Haiti, but has since been used by the guys in Nepal and other places, to 3D print for clinics who are missing parts. And all of that's available on Thingiverse. It's a slightly different way of working here. This was actually an NGO that came to Field Ready. They were having challenges training builders in a new method of construction following the earthquakes in Nepal. They needed to put in these reinforcements, but the builders were struggling to sort of train people through using drawings. And so the Field Ready engineers spent time with the NGO and came up with this design where people physically had to put the reinforcements in for the model to work. And this was laser cut, and they were able to laser cut a batch, within a week or two, to serve the needs of that NGO. So they were sort of a client. And then this is quite an interesting example, I think, because we were working with a local entrepreneur. This guy's making burners for stoves. He'd been doing his own research and development for a decade, really, carving things out of wood. But his designs were getting more complex, and so the engineer was able to work with him to 3D print a new burner design, which he then used to take into the sand casting process. and produce burners which met the 28% fuel efficiency for the government. And now he has an order book of 400,000. So what I quite like about this example is we were using 3D printing, but it was actually used in combination with traditional production techniques, like the sand casting, which were very scalable. And this is a little bit kind of a technology that we're playing around with at the moment. We're working in conjunction with the Polyfloss factory. Basically, you turn plastic bottles into a kind of candy floss-like material, which can be used directly as an insulation itself, or it can be used in something that's a bit like a giant sandwich maker to press into tiles, which can be used in insulation. And there's quite a lot of other potential uses for it as well. This is Ram, our engineer in Nepal. Yeah, and then I'm obviously going to talk a little bit about somewhere a bit closer to home and what we're doing there. I'd imagine people here are all very familiar with the Syrian crisis, the sort of near 500,000 presumed dead over the last 6 or 7 years, 12 million displaced. I think Greece is very familiar with that. So we've been working within northern Syria in Idlib. We have a workshop there with our engineer Osama and with Hamada and a couple of other sort of workers who help them out. They have concentrated on providing items that are needed by people in the area, which have been difficult or expensive to get. The first thing was this. This is a lifting airbag. It works like a jack, so it works like a jack that you might use when you're changing a wheel on a car, except it's inflated by air. And this sort of item is used by search and rescue teams around the world. It's, however, a bit of a niche product, and there's only a few manufacturers make them, so this one costs $5,000. In Syria, they had a few of these, which they were using quite successfully, but they just didn't have enough and weren't able to get enough into the country, especially in besieged areas. And so this is what we worked on. We had engineer Mark in the UK working with Osama in Idlib, going really right back to kind of concept development, thinking about what the search and rescue teams needed. A lot of prototyping and testing and iteration. We came up with this kit, and you can see it in action here. So this kit is made from heat welded polyester with rubber on the outside. So it's materials and tools that would be readily available in most areas of Syria, including in besieged areas. And it costs $460 to make, but it still meets the British standard. I can't remember the exact number. And it can lift 5 tons. It's been used already to rescue several people in Idlib after shellings. And we're just about to deliver later this week, we'll deliver the final batch of 25 sets, which we know will be going down to Homs, which is experiencing quite heavy shelling at the moment. So that's been our first success. Other things the guys have made out there, again, search and rescue equipment. This hydraulic lifter can lift nearly 10 tons. Some of the stuff has been a bit simpler. This aerial, it's an omni-aerial for radio communications, required quite a lot less concept development. It was basically, Mark was able to get a design from a telecoms engineer he knew, which is obviously a great benefit of having networks. But we are now able to make these aerials in Idlib for $20 instead of $200. And then another last thing that they're sort of working on at the moment is hydroponics kits, which you might have heard of. They're generally, I think, generally better known for being used to grow marijuana, but it's definitely tomatoes they're growing in Idlib. So an agronomist was interested in the idea, and Field Ready being able to put together the kit and the control element of the kit. And it's really sort of an exciting thing to be working on in Idlib, because it uses, they use about 1/8 of the water of conventional agriculture, and pumping water from the well is the biggest cost of agriculture in that area. So that's just a few examples of the kind of actual physical things we've made. And I guess now it's sort of to talk about how we're kind of expanding that. I'm sure you're all sort of familiar with the concept of makerspaces. This is a space that we have in Nepal. We have this within World Vision's Innovation Centre. It's quite a lot used by our own staff to make the things that you've seen previously. But where I think Field Ready is doing something a bit different with makerspaces, and the sort of exciting part for scaling up, is using makerspaces to come back to sort of shortening this supply chain. So we've already been looking at how we bring the manufacture, the making, and the communities together. Now the next stage is how to actually create networks of these makers and of the small manufacturers who together can compete with the global manufacturers. And the main platforms through which we've been doing this, really where we've been working with a big a group of different people, is MakerNet. And so MakerNet is an international collaboration which is about, as I said, about how to get makers, makerspaces, and small manufacturers to be able to fulfill these big procurement orders for the humanitarian and the development sector. We have Makerpedia. This was sort of set up as a part of the pilot we just ran in Kenya. And Makerpedia is the platform where the designs and the makers can all be sort of matched together. There's a back end around blockchains to manage the sort of the contract distribution and the financial side. This in Kenya started to sort of map out facilities and designs and how to sort of set up that side. We've just had a really exciting little trial run in Nepal. It was pretty small. It was a contract that we got from DFID to make a house like the one that you saw previously. And we subcontracted that to 3 different makerspaces. Actually, it was the first time that they used 3D printing. So it was a bit of a sort of a novel thing for them, but we were able to distribute that contract and get sort of 50 houses made. So it's very early stages, but I think it's a sort of an exciting first move. And we also currently just brought in an expert in blockchains to kind of to run a prototype of that back side of it. And yeah, I think this for me is a really exciting part. I mean, it's and kind of what got me really interested in Field Ready, alongside the amazing humanitarian work. But I think I come from a place in the UK which was I grew up in a very post-industrial place. I've worked in trade and investment in Vietnam and in Kenya, looking at how to grow youth employment. And I think, as has been touched on by sort of many speakers already, it's a little bit of a depressing topic right now. I think we're seeing there's many things happening in the world, but the way that sort of automation has replaced labor and has replaced so much job creation is it is something that's I think such a dramatic trend, and I don't know that this is going to sort of solve that problem, but I think the idea of actually having distributed manufacturing and that idea of putting some of that ability to make things and some of the sort of the revenue from making things back in the hands of people in the communities where things are needed is at least an attempt to move in a positive direction. So we say instead of having mass manufacturing, we now have sort of manufacturing for the masses. But a little bit back to the kind of the everyday reality. and what we're doing in Syria. So in Syria, we have this workshop in Idlib, where we have Osama and other engineers working right now, and they have been supported by our global team of engineers. That is continuing, and quite exciting. They're finally getting a 3D printer in transit as we speak. We're also building up the network around this. We're working with an NGO in Gaziantep in southern Turkey, where there's a huge amount of Syrian diaspora, who work a lot on building accelerators and working with young entrepreneurs and taking people through sort of design thinking processes. So we're helping them to actually physically set up a makerspace. This photo I was literally sent yesterday. This is the first bit of equipment arriving, the laser cutter, which the Khalid is looking quite excited about, I think. And so that will be supported as well by our remote team and by Humanitarian Makers, which is an online network of over 400 engineers. And we hope to see going forward, we hope to see these two centers working together to identify the things that are needed on the ground and work out the engineering solutions to go with them, and to have additional people, additional sort of small centers which will in turn be supported by them. So we're talking to people about organizations within northern Syria's healthcare clinics or schools or camps having their own small maker spaces, about having sort of mobile units and about having sort of community projects which are also using digital manufacturing and can be helped in the development and in working together to fulfill kind of the needs and demands. And that's where we want to see it going next. And be, very interested to hear other people's thoughts and opinions and ideas, and particularly about how we sort of can use the digital technologies to support that. Thank you. Oh, and if you want, I could just, I've got a bit of time, I just got a teeny little video of Osama saying hi. Oh. Sorry. Okay. Yeah, not to worry. It's yeah. They're basically saying hello, and thank you for your interest in what they're doing.
I want to send a message of thanks to the FAF Foundation, who are funding our work here in Syria to help Syrian people who are suffering from the current crisis. And we would love to wish you a very enjoyable conference from here, from Syria to Thessaloniki. Have a great time. Thank you.
Thank you.
All right, let's give a round of thanks to Susan and to her colleagues. So if you want to take this one. So we have about 10 minutes for questions, so I'm happy to run around and pass the mic. If anybody has any questions, just wave at me. For Susan. Okay, I'm coming your way. And it's important to have the mic because we do have a live video of this, so we want to make sure that people who are watching the live stream also catch the questions. Thanks.
Thank you. You said you had some units working in Turkey, yes? Doing stuff with the Syrian refugees there. How did you get by with the restrictions? There must be local Turkish restrictions on tax payments, setting up businesses and things like that. And often for refugees, that's the major impediment, rather than access to capital even?
So we're working with a sort of a Syrian organization which is registered in Turkey, and so we're providing, we're really providing the kind of the technical input, like how to use the different technology and the sort of the product development expertise, and we've partnered with them because they have the experience of actually working with refugees on the ground, and that's kind of what they bring to the table. I mean, in terms of, from what I know, but in terms of refugees starting up businesses in Turkey, I mean, people are. In Syria, in Turkey, Syrians are in a relatively strong position that they have the temporary protection does give them the right to set up their own business, and they are, they're allowed to work. It is a sort of an expensive process, I guess, if you're a very small business. But we're sort of working with people that are very, the people that are sort of going through the accelerator. It's really a first idea and a prototype. If people actually do have something that they want to take forward, then it's definitely not impossible in Syria. There are quite a lot of organizations that are helping people get registered and get official and pay the taxes where that's the stage that they're going to move into. I mean, and then of course a lot of people are sort of working in the shadows in the meantime. The Turkish authorities, whatever else, are quite supportive of the Syrian population. They're not trying to kind of prevent them doing stuff. So yeah.
All right. Any more questions? Yep. I see you. I see 2 questions. I think that's all we're going to have time for. So I'm going to go to you first. And to you.
Thank you. No, just a quick one, because you just gave us an overview. What kind of things they produce and what is needed? And also, when I'm thinking of the maker culture, I think of invention as well. Like necessity makes you, and self-production, kind of team production as well. Usually the maker culture produces innovation, new ideas, new solutions that we didn't think of before. So if you can give us a few examples of that.
Right. Well, I think there's sort of the examples that were in the presentation. I'm not sure if you sort of caught them, but for example, that we made we made an airbag from sort of first concept. We've made an aerial, a hydraulic spreader, a hydraulic lifter, hydroponic systems in Syria. In other parts of the world, we've made quite a lot of basic healthcare equipment. We've made wash pipe fittings and so on. We're doing a lot more now around, or sort of developing things around shelter, around insulation for shelter, around basic ways of ventilating tents and so on. Yeah. Inventions. Yeah. I guess, I mean, I don't know if there's sort of, a lot of this, I guess a lot of the things that have been made have been about finding replacements for items that people can't get hold of, or that are sort of, that they're broken, that they're running out of. And I think that's sort of been a lot of the immediate need. And that's because that's the sort of things that people are more able to identify that they need as well. In terms of actually sort of having kind of creative spaces, that's sort of what we're moving into now, I would say. Yeah.
Hi, thank you very much for that. I thought it was fascinating. I was wondering whether you have ever looked into collaborations with existing businesses, existing engineering businesses, about maybe secondments of their engineers or using their labs, or whether in fact you actually have to be mindful about infringing on their patents. Like, what is your relationship like with the original manufacturers?
Yeah, so I guess, so I think it varies, it depends. For example, for the airbag, we have recently been in touch with one of the major manufacturers of airbags, with the CEO, and he was very positive. Like, he was really enthusiastic about it and has offered to sort of do a little video to sort of say what we're doing is meets the standards that they would expect. But their business is primarily in sort of industrial applications, so I think we're very much not a competitive threat. And then for lots of other things where it's sort of small sort of spare parts and so on, I mean, it's not. In some cases, it's allowing their equipment to be continued to use and making it more functional, where otherwise just getting a spare part in is pretty sort of impossible logistically. And then in terms of, I mean, we're very keen to kind of work with manufacturers as well to kind of support them do research and development, or support them to actually take on making some of these things in a commercial way where that makes sense. And so that is kind of happening in Nepal. Some of the people who distribute medical supplies have been talking to our engineers about whether they can kind of take a 3D printer themselves so that they don't have to, so that they can be sort of producing nearer to where they're selling. And yeah, I think that's something we'd really like to pursue further, is getting that commercial side integrated. Because that's what we want to do. It's not like, oh, everything must be made by an NGO. Like, we're really quite happy for it to be taken up by businesses. And we're looking at that for sort of the airbag as well. But the whole import-export is a bit challenging.
Great. All right. Thanks so much for all your questions. And thank you again to Susan for her fascinating presentation.
Thank you.